Hey coders, welcome to the second part of this coding series where we are teaching Python fundamentals through actual practical programs. The first one we did was a hello world where we covered input and output. We're going to extend on that concept today by doing a guess the number game. Alright, so how this game is going to work is our program is going to randomly select a number between 0 and 10 for starting. We're going to run the program. We're going to say, hey, user, please guess the number. So the user is going to have to try to select the number that the Python program selected. Seems easy enough, right? But, if we're selecting 10 and we give one choice, only 10% of the time they'll get it right. Either way, this will give us the fun opportunity to extend some of those early concepts, get input from the user, validate some of that input, make our parameters of the program adjustable, kind of just build on that concept of building code, extending it, making it more maintainable over time. So let's get into doing that. All right, so to make this program, we're going to jump into our IDE again, which I already have that open. If you don't, open it up. Go ahead. I'll wait a minute. All right, so we're going to create a new file here. We're going to name this guessNumber.py, guessNumber.py. Again, .py is that Python extension to let our IDE know to give us that formatting and kind of use the Python module to give us some tools to make us more productive. So the first thing we need to do is we need to, we'll just add that copywriting in. All right, so to make this work, we're going to use the random module, which is part of Python's standard library. And that is just a bunch of useful pieces of code that we can pull into our programs to use some common functionality without needing to code it all ourselves. So that's another really handy part of the Python programming language is we have access to such a broad standard library to use. So I'll go ahead and show you what that looks like down here in the Python console at the bottom of the screen. So to get into that, we just run Python after we have it all set up, which we did in the first part of this tutorial series. And then to generate a random number between 0 and 10, 1 and 10, just random numbers, we're going to do something called importing, and we're going to import from the random library. So what this will do is give us access to a bunch of functions to kind of do randomy things. And for our example, we're just going to do random, randint, and then we're going to pass it into a 10 as part of its parameters, which the parameters are defined by the parentheses. All right, so that actually doesn't work. So we got a nice little type error there. Thank you, Python. So to do randint, I guess we actually need to give it the starting value that we're creating a number between. So yeah, we can just keep generating random numbers. Apparently it really likes 3. All right, not so much 3 anymore. So we saw 1. Does this actually give us 10s? Okay, so it does give us 10s, as we can see there. So randint, this will give us a number between 1 and 10. So let's pull this into our code. Doing the exact same thing we did in the Python console. We'll import random, import. Not what we wanted to do. Import random. This Python, so not Python, but so after typing import random, our IDE gives us other little things that have random. So on my system, I have NumPy and scikit or sklearn installed, which is kind of machine learning libraries, and this will let us see what different things we have installed within our Python environment that have a random function that we can import. Again, for this, we just want standard library. We can talk about installing things in more like intermediate tutorials, but we'll select that. And then number to guess. It's nice to use good specific variables. It makes it easier to read when you come back to your program later on down the road, like 3 months, 6 months, 2 years. That may seem like a really long time, but if you're actually in software development, you will definitely be modifying code that you wrote several years ago in a long-running program. So it's good to keep up those good standards and variable names and follow the other kind of Python conventions around keeping your code clean and readable. So our number to guess is just going to be a random rand int from 1 to 10. So that's good. And then we need to give some feedback to the user on what our program is doing, what kind of input we are expecting. So we will go ahead and use that built-in print function again. Hi user, welcome to guess the number. And then user's number equals input. Enter your guess. We'll go ahead and use that next line character again so that the input will be on a clean part in the terminal. And then now we're going to use something new called if-else conditional logic. This allows our program to actually choose between doing different things for different values. In this case, if the number is the number that we actually got in the random thing, we're going to say, congratulations, you picked the right number. Otherwise, we're going to tell them, this is not the right number, you lose, sorry, try again. So, again, as we said before, input will automatically read in anything as a string. So we're going to want to cast this to an int. And Python lets you do something called method chaining. So we're taking the input, which is a method, and then we're taking that value that the user puts in and we're feeding that as the input for the int method. So by calling multiple methods in a single line, it makes the code a little more readable. That's not always true. You want to keep things intuitive when you're writing your code. But in this case, it's just two pretty self-explanatory methods that we're calling. So we're going to go ahead and do that in one line. If user's number, not sure what happened there. So the other thing with our conditional statements here is we need to compare values. Some of the most common things that you will see is if user's number is less than, is greater than, or equals. In our case, we're going to do equals equals. So if the guess equals the number to guess, we'll just print congratulations, you picked the right number. Else, so this will be the second part of our conditional. So with this logic, generally you'll see it in a pattern like if, elif, so else if, and then you feed in another statement. And then if it's not either of those, you will have a last else statement, which will just kind of run something by default. So if it doesn't meet any of the conditions above, just do this line of code. You don't always need the else statement if you're just doing simple ifs. Maybe we'll see some examples of that, but probably not for beginning programming. We'll just stick with if and else. Print, I think I also spelled congratulations wrong. I did. So this is a T. Sorry. All right, so print, congratulations, you picked the right number. If they didn't pick the right number, print, sorry, the correct number was, and then we'll use our cool little fast formatted strings again, number to guess. And then we'll put an F in front of this to represent that we're using those F strings. All right, so this should be a working version. Remember that this is only going to work 10% of the time. For the case of having something that we can actually win, we'll set this to 1 to 3. All right, so now that we have our code here, we'll go ahead and run this in the terminal. All right, hi user, welcome to guess the number. Enter your guess. I'll guess 2. Congratulations, I picked the right number. Apparently it was 2. And then we'll run this again just to show that it will show that other line if I'm wrong. All right, enter your guess. We entered 3. Sorry, the correct number was 1. Now, this doesn't really make that much sense because, you can only do this one time. So we'll use something called loops to do this a little more. And also, if we put in something like enter your guess is 5, blah, invalid literal for int. So as you can see, the input is always expecting a number. If it's not, our program errors out, and generally you want to be more dynamic in your error handling, so we're going to fix that as well. Another thing with this is when you enter your guess, it doesn't actually tell us kind of what the range is that we're supposed to be guessing. So we need a little more dynamic feedback to the user as well. So that's something we need to be aware of. So if I enter your guess as 10, I'm never going to be right because it's only going to be 1 to 3. The user doesn't actually know that when they're running this program, in which case this would be really bad user experience. So another thing you really want to be aware of when coding is presenting a good user experience, giving good output messages to the user so they know how to interact with your program. So we'll go ahead and fix that by adding a few lines in here. Max number equals, for our example, we'll stick to max number equals 3, randint equals 1 to max number. Now the reason we're doing this is because this will allow us to use this variable, set it in one place, so if we have to modify it, we're not modifying multiple lines of our code and causing ourselves extra time. We'll just store that in one place up top. All right, so originally our output said, "Hi user, welcome to guess the number." We want that to be a little more dynamic. Please guess a number between 1 and this is where we want to use our max number variable. And we'll do that using a formatted string here. So to designate that, we add the F in front. Go ahead and save that, run this in our thing. Please guess a number between 1 and 3. So now I know that I'm guessing a number between 1 and 3. I can still enter something else, and it's always going to be wrong. And that's where we want to validate our user's input. Well, let's extend our code to do some validation for the guess. All right, so to do the validation, we're going to do is valid equals false. What this is a Boolean variable, which is either equal to one of two values, true or false. We're going to automatically assume that the input is always false because we don't actually have any input yet. We want to present the user an opportunity to keep entering their guess until they put in something that's actually valid. Generally, you will assume that they'll always put in something valid, but that's not always the case. And if they do something wrong, you don't want to fail the thing automatically. You want to loop back and give them the opportunity to fix it. To do this, we're just going to use a while loop, which will keep executing the same bit of code until the while condition ends up being true. While not is valid. That will keep executing this bit of code until they actually put in something that's valid. Like I originally said, this input will always be a string. And then we're always going to try to convert that into an integer. If they put in something that's not a number, as we saw before, that's going to error out. We're going to use something called a try except, which will automatically look for that exception value that gets thrown by Python, and will give us the opportunity to do some correctional code based on the exception. For this, we're just going to use a generic exception. You can have it accept multiple types of exception for your code to be more specific. That's a little too overwhelming for what we're trying to do right here. So we'll just use basic try except, print the value you entered was not a number. So that's the only time we're going to hit this except is if they put in something that's not a number. And we don't need to we don't want to run any code underneath this because the user has done something bad. We want to go back to the beginning of our loop to give them an opportunity to fix what they did and put in a correct number. So to do this, we'll just continue, which will go back to the beginning of our loop. So now the other conditionals we wanted to check is if they put in a number between 1 and 3. So we want to see that it's actually the correct number. So if user's number is greater than 0 and user's number is less than or equal to the max value or the max number. So you can see we're getting reuse out of this max number variable in several places in our code, which is the benefit of using variables. Then we'll set is valid equal to true. So now that is valid equals true here, and we have a conditional on our loop while not is valid, we're going to go to line 21. We're going to set is valid to true. We're going to go back to the beginning of our loop at line 12, and we're going to see that is valid is actually true, and this is no longer a valid case anymore. That's going to stop the execution of our loop and go from line 12 down into line 23 and start running the rest of our code. But we don't actually want to finish this completely yet. Our validation code is not completely done, because if they put in the value it's 0, they're not actually going to know that they put in the wrong value. We want to give some more output to the user to let them know that they did something that was wrong. So now that we have a way to stop our program if the input is valid, let's talk about what happens if it's not valid. It's going to go to this if user's number is greater than 0 and if user's number is less than or equal to the max number bit of code. And it's going to see that it's not one of those cases. So we're not actually going to change is valid. Is valid is always going to be false here. So we're going to go back to line 12. We're going to see that our code is still not valid, in which case we're going to go back into our loop at line 13. We're going to redisplay the message to please guess a number between 1 and the max number. This will give some feedback to the user that they didn't do something that was expected, and then it will give them the opportunity to fix that. You could also do something like change the color of the output to let them know that, like, hey, this was not correct, go ahead and fix it. But for the sake of this guess number tutorial, we're just going to represent the original message and just utilize our loop to keep going through until they put something that's correct. I'll go ahead and run this right now, and we'll input in some invalid input. It's expecting a number between 1 and 3. So if we input 4, this is not going to be correct. It's going to go back into our loop. It's going to say, please guess a number between 1 and 3. So again, let's input something that's wrong, -20. So that's our less than case. As you can see, we went back into the loop to please guess a number between 1 and 3. What if I want to guess 2 now as a string? So the value you entered was not a number. Please guess a number between 1 and 3. So let's go ahead and actually enter a valid number. Let's enter 2. Congratulations, you picked the right number. My input was actually a number, and it happened to be the right one. We got the cool little output that we won the game, and we picked the right number. Awesome. What else can we do to extend this? What if we give the user multiple guesses? If we're trying to guess a number between 0 and 10, you're not going to get it very often with just one guess. Let's give the user 3 guesses. All right, so as we just talked about, we're going to make it so we can have a certain number of guesses for this. To do this, we're going to go up to the top of our code where we input kind of our little configuration variables. And we're going to do max guesses. So we will also set this equal to 3. And let's make our code a little more readable by adding some nice comments. This will help future developers working on this code. And it'll also help you down the road if you have to come back and look at this. So this will be our standard library imports. Let's extend our kind of header commenting to be a little more descriptive. Author, Stephen B. Module, guess the number game. Description, teach people loops and conditionals by coding a basic guess the number game. So now when I add this to my GitHub, which that'll be kind of one of the later videos, I'll probably release that afterwards. Go ahead, like and subscribe if you haven't already, so that you can get that content when it comes out to learn how to use Git more. Again, once I push this up to Git, if someone else is reading this code, they'll be able to clearly see when this was created by the push date, the copyright, who the author was, if you have multiple people contributing to a code base, and a little small description of what the objective of this code is trying to do. Again, let's add some helpful comments in here. Configuration variables. Our number to guess. get input from the user and ensure it is valid. All right, so now that we have some nice comments in here, you can kind of see how the formatting is coming to play from our IDE. Comments are green, strings are this kind of orange pinkish color. Stuff that's squiggly line is invalid. Kind of our important keywords within Python are highlighted in pink here. And then our Boolean values, why is this still undefined variable? Okay, that was weird. I don't know why that was still squiggly lined. Let's think through how this is going to change the program now. A user is going to input a guess. If it's wrong, we need to give them the opportunity to put in their guess again. That sounds like another loop case that we'll end up needing. The interesting thing here is within our number of guesses loop, we'll also need to do a loop to check that the input they're putting in is valid. So that's kind of the code that we already used. What we could do is we can move this into a function to make it a little more modular if someone is using this. And we can also move that into another file. That starts to get a little complicated. I think even the function might be a little complicated for what we're trying to do here. In this case, we can use nested loops, which is a loop within a loop. So before we get into our nested loops, we actually need a variable to track how many guesses we've done so far. So we'll initialize this to 1. And now we'll go back down here to our loop, and while number of guesses is less than or equal to max guesses. So this will give us the opportunity to do a little more guesses. We need to add this logic within that first loop. And then if the number they pick is actually right, we're going to stop the loop. We don't need to do any more guesses because they picked the right one. So we can just break this loop, which will stop the execution of it. And we'll go to line 43. But in our case, we don't have anything at line 43, so it will just stop the program. If they didn't pick the right number, then we want to up the number of guesses that they've done so far so that we can keep track of when to stop our loop. And we also want to display to the user that they want some more guesses. And in this case, we don't actually want to give the correct number when we go to redo the guesses again. So we're actually going to use our elif statement here. Elif number of guesses is less than so I'm just realizing we're checking number of guesses here, and we're also checking number of guesses here. This isn't the most efficient way. You can maybe store a Boolean flag like keep playing, and then you can set this. But we'll continue on with this logic. If number of guesses is less than or equal to max guesses, we'll go ahead and add 1 to the number of guesses that the user has made so far. And we'll use this little plus equals operator, which will just take the original number and then add this number onto it. If you didn't do it like this, you could also do something like this, where you have number of guesses equals number of guesses plus 1. So as you can see, the line above it is a little more efficient, it's shorter, it's kind of easier to read. That's why I like using plus equals operators. You can do that with any kind of operator, the minus, multiplication, division, and then even some of the other fancier ones like the modulus operator can also be done in that fashion. All right, and now that we incremented the number of guesses, let's go ahead and print a message to the user to let them know what's going on. You did not pick the right number. You have some number of guesses left. Guesses left. So I think we actually want to initialize this to be 0. And we want this to be less than the max guesses. After the first time of running this program, they're going to go ahead and guess a number. We're going to increment this to the number of guesses they made so far, which will be 1. For this, inside of the f strings, we can also do Python expressions. So we'll make this an f string, and we'll have this be max guesses minus number of guesses. Well, this should actually say they have 2 guesses left, and then after you input again, you have 3 guesses left. Now let's also change our program to have a broader range of numbers that we're trying to guess for. So we'll do that by going up into our configuration variable section and changing this to 10. And let's run our code now and see how this works. Looks like we have some invalid syntax somewhere. Oh, and that's actually because we're still in our Python interpreter console fun guy. All right, let's go ahead and run this now. Please guess a number between 1 and 10. Enter your guess. And again, we still have that validation code where if we input something wrong here, we'll get the chance to keep re-entering things. And this won't actually affect our number of guesses. So let's guess 7. And that actually did not do what we wanted it to do. This is a good example of needing to reinitialize your variables. Before, we had this while not is valid flag. Since we set this to true right down here, we're not actually going to be able to get the chance to update our input. What we need to do is if their guess was wrong, we actually need to reinitialize the is valid flag to false, and then that will give us a chance to update our input. So we'll do that here, where this is our little conditional statement where our number is wrong. Is valid equals false. We'll flip that flag back, and that will give us the chance to enter new input. Let's see that that works. Enter your guess. We'll go with 7 again. You did not pick the right number. You have 2 guesses left. Please guess a number between 1 and 10. Let's do 3 again. We could do something really fancy here where we don't want to let a user guess a number that they've already guessed. To do that, we could kind of keep track of a set, which is another data structure. But to keep this a little simpler, we're just going to assume that they'll pick a different guess. For our next guess, we'll put in 3. You did not pick the right number. You have 1 guesses left. Again, this is not proper English. You can do some more kind of logic checks where if the number of guesses left equals 1 to display the text guess. That's if you want to kind of productionize your code and make more sense for the user. This is just a toy example, so we'll leave it as 1 guesses. And we already guessed 3 and 7. It would be nice if we also presented that you have already guessed 3 and 7, please enter something else. So this is kind of like opportunities to keep updating our code and adding functionality to it. But for our sake, 9, you did not pick the right number. You have 0 guesses left, and it looks like our code quit. That's not exactly what we wanted to do. We wanted to go into the else statement where it said, sorry, the correct number was blah. Interestingly, this did not do the right thing. So I think what we want to do is we want to actually check if number of guesses equals max guesses minus 1. That will give us the opportunity to increment it and then go into the next conditional. This is kind of like an off by 1 problem, which is really common when you're having while loops and different flag checking. And most of the time you can kind of find that through writing good integration tests, through manually working through your code. And that's why it's always good to do that instead of just shipping code automatically and assuming it's correct without actually testing it yourself through an automated method or through manual verifications. As we can see through our testing process that our logic was a little off, so we added the max guesses minus 1 into here, which should give us the opportunity to hit this statement. Let's do our program again. All right, enter your guess. We got 7, we guess 3, we'll guess 9. Well, this is our 3rd guess, and if this isn't right, we should get the message that says what the correct number actually was. Sorry, the correct number was 2, and it looks like we hit a case in our loop where we get an infinite execution. If we actually ship this in production code and we didn't properly break our loop, that would be very bad. To get out of this, we're gonna stop our terminal here. Stop this window, and if we hit this case, we'll break our loop. The reason we're doing that is because we're not actually incrementing our number of guesses. So we're not going into this. And then we're not resetting our isValid flag either, so it just loops and loops and iterates, and eventually if that goes on long enough, you have a chance of freezing your computer. So that's why it's really important when you're using loops to check your break statements correctly and to make sure you don't hit those infinite loop cases. Now that we're properly breaking our loop, this should be a complete game, and we can go ahead and run this. We'll go with our typical guesses that we've been using here. 7. We actually picked the right number. All right, let's play this again. Enter your guess. 7. 3. 9. Sorry, the correct number was 8. We have a working game here where we have good user experience, good output to the user. We're doing our validations. We have our conditional statements to check our number of guesses and to check if we're right. This is more representative of what an actual kind of Python program would look like, where you're doing those good validations and having those different conditional checks. If you were to keep growing this game even more, you would want to start modularizing your piece of code so it doesn't start getting really long, and it'll be harder to understand for newer developers. It'll be harder to understand for you coming back to it. And that's where you want to have your really good kind of design patterns start to come into place, which is more intermediate programming. All right, I hope you enjoyed this tutorial. Go ahead and leave a like if you learned something, and keep following along. Thank you.